Hi everyone, this is VK. Welcome to Smid World. Here I am with another video. In this video, we'll see about bucket elevators. Bucket elevators are the most efficient means of elevating free flowing granular materials and most materials, even some sticky materials. Type of bucket elevators: belt bucket elevators, chain bucket elevators, both economical and reliable. Belt type bucket elevator with the traction belt as a traction component. Bucket elevator continuously upward convey materials through the hopper fixed on the belt, which adopted fabric or wire rope core rubber belt. Features and advantages of a belt type bucket elevator: sectional friction lining of the drive pulley may be effortlessly replaceable without dismounting the belt. The wing pulley was mounted within the tail section to forestall the materials from the scattering on the pulley to reduce the friction between belt and pulley. Traction components adopt a specialized rubber belt of the bucket elevator, which is of the high tensile strength, good flexibility, and long service life. Fourth point, a gravity tension device is adopted in the tail part of the bucket elevator to realize the automatic tension of the belt. As long as the adjustment is in place, the constant tension can be maintained to effectively avoid the belt slipping. Both ends of the belts are clamped into the aluminum cast composite box clamp connection, thus securing the belt connection. Buckets are mounted on the belt with a specially designed flat head screw, and rubber strips are put in between buckets and also the belt. Chain type bucket elevator. Chain bucket elevator adopts high strength chain as traction components. The chain bucket elevator is fixed on the high strength chain using gravity unloading mode for the continuous lifting of material. Very suitable for large capacity lifting scenes, which is perfect solution for powder, granular, block, and high temperature material vertical transportation. The features and advantage of chain bucket elevators are: first point, the head sprocket consists of hub and a split ring gear. When the sprocket wears out, the gearing may be easily replaceable when the maintenance budget is saved. Tail sprocket with high teeth effectively prevent tail sprocket with light teeth. Effectively prevent head and tail out of synchronize caused by tipping teeth and wear. Traction components adopt steel wear resistant sleeve roll chain, which might effectively cut back the wear and tear of the traction parts. The guide rails are put in within the housing to stop the chain from swinging throughout the operation. The automatic tension of the chain is complete by employing a gravity type take-up device at the tail section. Once the adjustment is in place, the constant tension will be maintained, effectively avoid the chain from falling off. Because the entire housing production is good, therefore no material and mud leakage, environmental pollution free. Types of bucket elevators. You can see in the picture, centrifugal discharge and positive discharge. Type 1, Type 2, Type 3, Type 4, Type 5 is under centrifugal discharge. If you see for centrifugal discharge, elevators of this group handle bulk material that is fine, loose and free flowing with small to medium sized lumps. Material is discharged from these elevators by centrifugal action as the bucket passes over the head sprockets. The first four types below are generally furnished with a AA or HS buckets. Type 1, fixed head shaft, internal gravity take-ups on foot stop. Type 2, similar to the Type 1 except adjustable head shaft, fixed foot stop. Type 3, fixed head shaft, screw take-ups on foot stop. Type 4, similar to Type 3 except adjustable head shaft, foot shaft. Type 5 separated runs take up on foot shaft and HS buckets. Type 14 fixed head shafts, internal gravity take-ups on foot shafts AC buckets. Type 15 fixed head shafts, internal gravity take-ups on the foot shaft ACS buckets. If you come for positive discharge, Type 6 elevators operate at low bucket speeds and can handle light, fluffy and fragile material. Buckets invert over discharge spot providing positive discharge. Type 6 fixed head shafts to take up on foot shaft buckets mounted between two strands of the chain. Type 7, Type 8, Type 10, Type 11 belongs to continuous flow. Type 12 and Type 13 belongs to internal discharge. Continuous flow of this group handle bulk material ranging from light to heavy and from fines to large lumps. Buckets are placed continuously and are loaded by direct feeding. Type 7 fixed head shaft, internal gravity take-ups on foot shaft. Type 8 similar to Type 7 except adjustable head shaft, fixed foot shaft. Type 10 fixed head shaft, screw take-ups on foot shaft, super capacity buckets mounted between two strands of chain. Type 11 similar to Type 10 except head terminal, machinery and drive equipment are carried on independent supports. Internal discharge. These elevators handle small bulk articles such as rivets, plastic chips or shelled nuts grandly and continuously. Buckets are internally loaded and discharged from either side of the elevator. Type 12 slow speed unit with a fixed head shaft and a gravity take-up on foot shaft. Type 13 similar to Type 12 except double head shafts for higher speed operation. Centrifugal discharge. Buckets for centrifugal discharge. Centrifugal discharge elevators are boot take-up and head take-up. Both are available with buckets mounted on a chain or a belt. The centrifugal discharge elevators will handle free-flowing materials small to medium lump size. The inlet chute and cover bottom plate helps direct the material into the bucket, reducing the digging action of the bucket. The speed of the elevator is sufficient to discharge the material by centrifugal force. Continuous discharge. Continuous discharge elevators are offered as boot take-up and head take-up. This is available with buckets continuous mounted on chain or belt to handle many bulk materials ranging from light to heavy and from fines to large lumps. The buckets are loaded by direct feeding with the use of loading line. Spillage of material is minimized by the closed bucket space. As buckets discharge, material flows over the preceding buckets, projecting sides of the chute, assisting in proper discharge. Centrifugal discharge buckets elevators are specially designed to economically handle grain and other free-flowing materials weighing less than 60 pounds. Continuous discharge buckets mounted between two strands of heavy-duty chain. These elevators are usually where higher capacities, larger lumps, severe duty or higher shaft centers are required. The feeding and discharge of material is similar to a standard continuous discharge elevator. Centrifugal discharge. Types of buckets. You can see here for centrifugal style, buckets for centrifugal style and buckets for continuous style. AAS style buckets are centrifugal style, generally used for dry, moderately free-flowing material that is not easily damaged. The smooth curved bottom and angled front face of the AAS style bucket provides efficient product discharge. AA buckets typically do some digging during operation and therefore have a reinforced front edge or longer life. Typical applications you can see here: the sand, rock, aggregate, stone, fertilizing, clay, salt, coal. You can see cement and clinker, etc. AC type buckets. AC or added capacity style buckets are centrifugal style, used for dry, free flowing to moderately free flowing materials that is not easily damaged. The AC style elevator buckets have a high front for increased capacity. The angled front face and hooded back allows for closer mounting. Optional vent holes can help efficiently fill and discharge material. AC buckets may perform some digging of product in the elevator boot during operation. They can mount to a reinforced multi-play elevator bed or to chain. C-type elevator buckets are centrifugal style buckets. They typically handle wet or sticky products, firmly pulverized material or product that easily pack. The open front face and angle slides allow the discharge of material trapped by the other bucket designs. The C-type style buckets are low profile, permitting more buckets per foot than some other styles. MF style bucket elevators are commonly used for the continuous style with a medium front for slow speed product discharge. They gently handle dry and fragile and powdery, dusty or abrasive materials. The angled face aids in product discharge and extended side panel bottom edges create a chute to direct product pouring from the previous buckets into the discharge. Optional vent holes can help provide maximum fill and product discharge. MF buckets are not designed to dig through material in the elevator boot during operation. HF style elevator buckets are continuous style with a high front place for a greater capacity, designed for low speed product discharge. They gently handle dry, fragile, powdery, dusty or abrasive materials. The angle front face aids is in product discharge and extended side panel bottom edges create a chute to direct product pouring from the previous bucket to the discharge. Optional vent holes can provide maximum fill and product discharge. HF buckets do not dig materials in the elevator boot during operation. SC style elevator buckets are continuous style for use with super capacity elevators. SC means super capacity elevators and have increased capacity. They are designed for slow speed product discharge and very heavy materials. The angle front face aids in product discharge and extended side panels create a chute to direct product pouring from the previous bucket into the discharge. The optional vent holes can help provide maximum fill and product discharge. SC buckets do not dig material in the elevator boot during operation. You can see here the difference of centrifugal discharge and continuous discharge. In centrifugal discharge, standard and AC style, high speed grain. In standard, chain and belt. In AC style is belt chain. High speed belt, you can see the differences body structure. Continuous discharge, standard, chain and belt. Super capacity, you can see the chain. Components, accessories, conveyor pulleys, and engineered class sprockets and traction wheels. These figures are only for example. Operation and maintenance of belt elevators prevent overload. For bulk material handling, conveyor or elevator, flow of material should always be regulated at a rate within elevator capacity, where surging and overloading are invited. A surge hopper of adequate size should be provided from which material can be withdrawn by a suitable feeder. Overload protection can also be provided by the installation of shear pin hubs. Backstops or handbrake can be provided to prevent backrun of loaded elevator in the event of power failure. Starting and stopping. To assure long life, Wherever possible, the elevator should be empty when starting and should be stopped only when again empty. The starting under load not only places extra strain on the equipment but also frequently contributes directly to breakdowns. This is particularly true when handling bulk material that tends to settle or freeze, since a very great pull may be required to break the load loose. Elevators, unless empty, will run backwards. The backstop can be provided to prevent this. Elevators should be operated at regular intervals during any extended down period to avoid freeze-ups, at least once a week or preferably turn over once each day when sticky material are handled. If you see the maintenance view, large elevators provide suitable walkways and where necessary platforms, stairs or permanent ladders for access. Provide proper protection against the elements, extreme cold, rain or snow and sleet, and provide pipe extension of a difficult to reach grease fitting or automatic greasing system. Provide adequate cleanup of turbulence and spillage. Set up a specific lubrication program and fix defined responsibilities for carrying out procedure. One successful method for accomplishing this is to be prepare master lubrication check sheet or card for each important conveyor or elevator. Establish a defined program of inspection. Elevator belt should be checked for wear, stretch, edge wear, indication misalignment or material buildup on pulleys. The pulley should be examined for alignment and positioning. Bucket should be examined for looseness or damage. All belts should be checked for proper tension, enough slack to flex slightly, if too much slack is present, take up should be adjusted and take up excess slack. If you come to the operation, a continuous or centrifugal bucket elevator must have a controlled load delivered to it for proper and trouble-free operation. If the load is not fed uniformly but delivered in surges, the elevator can be overloaded. This causes the boot to flood, resulting excessive overload to the machinery. It comes to alignment, centrifugal chain elevators. With the chain, the alignment of the elevator is normally very easy to maintain. The sprocket on the tail shaft normally is tightened down enough. The sprocket engages the chain and guides the chain in the loading area. No tension is required in the chain to develop driving friction because it is taken care of the sprocket itself, the self-weight. Centrifugal elevator's belt. When a belt is used, the tail pulley should be tightened enough to provide the tightening effect of the tail pulley itself. Instances, it is necessary to develop the driving friction or some part of the driving friction from the tail pulley. If the weight of the buckets and belt is not enough to develop the friction at the head pulley, then the screw take-up should be tightened enough so that no spillage occurs in the handle, the design capacity of the bucket elevator. So note that the boot shaft must rotate at all times while the elevator is in operation, showing that the belt is in contact with the pulley and is being trained by it. Gravity take-ups, type of the take-ups you see here. First, one is the gravity and second one is screw take-up. First, when gravity take-ups are furnished in the boot sections, the take-up weight is normally just significant to engage the sprocket or pulley and provide proper tension. When hot materials are handled in elevators, the gravity take-ups ensure proper engagement of sprocket on the chain when the chain elongates with the increases temperature. It is possible that the gravity take-up is also used to create driving friction on belt elevators, with general arrangement drawing giving the maximum counterweight of the take-up for the particular application. It comes to screw take-up in boot section. When screw take-ups are tightened, they should be adjusted so the tail shaft rotates, or in case of driving friction, the tighten enough to create the required driving friction between the belt and head pulley. This is common normal bucket elevator components. This is for general purpose. You can see in the picture.